Imagine this. On a planet, the CO2 levels are increasing. With the increasing CO2 levels, the temperature rises. The pH levels go down, causing extreme ocean acidification. The oxygen decreases. There is no longer air to breathe. Both land and marine life perish. Well, that scenario is the situation occurring on Earth right now. And we need to find another suitable planet for life. And that planet is TRAPPIST-1F. Greetings. My name is Adia Walsh. And today, as I have just said, we are going to go over how we can find another suitable planet for life and why that planet is TRAPPIST-1F. Now, we begin with part 1. These are the things that make Earth habitable. There are many things that make it habitable, but these are the main 3. First off is oxygen. Living things need oxygen to breathe. We use that to survive. Without oxygen, we cannot breathe, which means we can't survive. It is a very crucial element that we need to survive. Also, in the excerpt packet on page 6, we can see that after oxygen left the ocean's atmosphere, biodiversity began to increase. This shows us that oxygen is one of the main causes for life on Earth. Now, liquid water. These two things have a correlation relationship. Living things need liquid water. And according to science experiments on YouTube, without liquid water, plants would dry up. With the dryness of plants, animals that need plants to survive would die. Without plants, they cannot produce photosynthesis, which means we get no oxygen. So liquid water is a crucial thing that we need on Earth. We use it to clean ourselves, to quench our thirst. We need liquid water. Now, let's look at this model. This right here is the sun, and this is the energy or heat it gives off. The heat the sun gives off is the heat that we get on Earth. Let's talk about evaporation. When there is water and the water is interacting with the sun, the water evaporates into vapor. This is what happens when planets are very close to the sun. If a planet is right here, the distance from the sun is very short, which means that all of the water in that planet has evaporated, aka turned into water vapor. When a planet is too far from the sun, it barely gets any of the sun's heat/energy, which means it just stays as ice. Now, when a planet like Earth is at just a great distance from the sun, we have liquid water. This is why these two things correlate. The distance from the sun determines if the planet has water vapor, liquid water, or ice, which means this is very important. Great, so we just solved the things that make Earth habitable. Now, you may be thinking, okay, if the Earth is so habitable, why do we want to leave? Great question. How is the Earth changing? So if you remember what I said at the very start of the video, CO2 levels are increasing. And as I said, when CO2 increases, the temperatures increase. The pH levels go down, which causes ocean acidification. When there is more carbon in the atmosphere, there's less oxygen. And as we said, oxygen is a crucial thing that living things need to survive. Without oxygen, we cannot breathe. And when we cannot breathe, we don't survive. As we see, as the years go by, the CO2 increases. And the more it increases, the more the oceans begin to have oceanic acidification, the more marine life begin to die, and the more humans struggle to even take a breath of air. Also, according to our Unit 2 project packet, sea levels are increasing rapidly each year. In a few decades, these sea levels are going to take over land, and soon it is going to be underwater. We need to get out before this even happens. So now that we know why Earth is changing and why we need to find another place to live, how do we find that place? What are the characteristics we're looking for? Well, in part 3, we are going to focus on the sun that we need to have a habitable planet. Now, we have talked about the distance from the sun where a planet can have liquid water. Well, that is just called the habitable zone. It's a shortened down and a scientific way of saying all of those words. The habitable zone. The habitable zone is different depending on the star type. Different kinds of stars give off different kinds of energy, and there are 4 main stars. Supergiants, giants, main sequence, and white dwarfs. Now, as I said, the habitable zone is different because different stars give off different amounts of energy. And as you can probably assume, these stars are massive. They are so big that the human brain probably cannot even comprehend how big they are. So, to have something that massive, it must take a lot of energy, which means that these stars require a lot of energy to be stable and run. But because these stars are using so much energy and they give off so much energy, they die faster, which means that these 2 stars cannot be useful to support life. Now, here we have main sequence stars. And if you can see, it says main, which makes us think, Now, if we look here, we see main sequence stars. Can you guess which one our star is? Main? Yeah, you guessed it. Our star is a main sequence star. Sorry, our sun is a main sequence star. Main sequence stars give off just the right amount of energy. They are not giant like these stars, and they're not too small. They're just right, which is why they are wonderful in supporting life. These stars are the kind of stars we want. And our star, as you can see on the ESSER packet, our star is a main sequence star with the color yellow, and it is about 5,900 degrees Kelvin. If you're wondering what Kelvin is, it is just a made-up unit so we can understand how hot that star is. Okay, now, when we want to find out if something is good for life or if something is going to make life habitable, we look at the Earth and the things that Earth uses to be habitable. So if our sun now, a sun that is stable and allows us to have everything that we have now, is a main sequence yellow star with 5,900 degrees Kelvin, we are going to look for another star that is main sequence, possibly yellow, and about 5,900 degrees Kelvin. Okay, so now we know that we are possibly looking for a star that is main sequence and has these characteristics. So, what is a white dwarf? Well, white dwarfs are possibly the second best star to have. These stars are smaller and take longer to form, but they are not a terrible option. They are a good placeholder to have while we search for even better life in the solar system. So yes, we can definitely use these stars to support life, and they're not a bad option. It's just we rather have a more stable star such as a main sequence star, but if there's a case where we cannot find a star like this, white dwarfs are the next best thing. Okay, so now that we know what the habitable zone is and that it differs depending on the kind of star, we need to talk about if the habitable zone changes. And the answer is yes. This is because as a star gets older, it becomes hotter. When it gets older, it is giving out more energy that it has used throughout its life. It gives that out, and therefore it's hotter. Let's look at our previous model now. So this is the sun. This is the energy that it gives off. This is a planet, and this is where the sun had. Okay. This is the sun, and as we said, right here is where a planet is going to have liquid water. Now, as that star gets older, as we said, it gets hotter, which means it's giving off more heat and more energy, which means that the area where a planet gets water vapor goes up. So if this is giving off more energy, more heat, this is no longer going to be liquid water. It's going to be water vapor. And now this will be the point where a planet has water vapor. This will be the new point where a planet has liquid water. And this will be where a planet has ice. You see how much of a drastic change that was? The water vapor went from being in this area to right here, all because the planet gave off more energy, which means this is no longer the habitable zone. No. Another reason why planets go out of their habitable zone has to do with the eccentricity of their orbit. Eccentricity. I know. I'll explain. So, If this is the sun, this is the planet. This is its habitable zone, this circle. As the planet orbits and it stays in the habitable zone, it is going to maintain liquid water. But if during the planet's orbit it goes out of the habitable zone, it's not going to have liquid water anymore. It's going to have ice. Or it could be closer. It's going to have water vapor. This is called eccentricity. And eccentricity is the more oval shaped it is because it's going out of the orbit. It's extending. So instead of staying in its habitable zone and going in a somewhat circular orbit, it becomes oval shaped and goes a bit out. So that is what eccentricity is. And we can think of it like this. When the eccentricity number is closer to 0, it is more circular. When the eccentricity number is closer to 1, it's more squished, oval shaped. That's how we can think of it. It's a very useful tip. So, when we say that the distance of the habitable zone changes, don't think that the planet itself is changing its distance. That's not what's happening. The distance from the sun is called AU. It stands for astronomical unit. It's a made-up unit that we use to better comprehend how far a planet is from its sun. For example, instead of saying that the Earth is 1,000 million miles away from the sun, we use AU. And by the way, that was a completely made-up number. I don't know how far the Earth is from the sun. That was just an example. So, an Earth's habitable zone is actually from 0.9 to 1.5 AU. So we should keep that in mind. Now, when we say that the habitable zone's distance changes, the distance of the planet from the sun does not change. When the habitable zone changes, this does not get pushed back. The planet, it still stays in the same area. It's just that if the planet had liquid water, since the habitable zone was pushed back, that planet is too close to the sun now and now has water vapor. It's the phase that's changing. Think of it like that. The planet itself does not move. Keep that in mind, okay? So now we are looking at the question, how do we find a planet that supports life? Okay, well, to find a planet that supports life, we are looking at a few things. This includes the planet's size, how rocky a planet is, and its atmospheric composition, aka chemical composition. Now, Earth is not a big planet whatsoever, not even close. Earth is a pretty average sized planet. Compared to many other planets, it's not big. So we are looking for a planet that is, of course, about the size of the Earth. Because as I said, when we are trying to find another suitable planet for Earth, we look at the things that Earth has and we use those things. We look at the characteristics of Earth to find another Earth-like planet. So we want a planet that is about the same size as Earth. All the things that the Earth has, that is what we are looking for in another planet. So size. The size should not be too massive, but it should not be tiny. Now, rockiness. Well, when we say rocky, we are talking about Jovian planets or terrestrial planets. Jovian planets are gas planets. These planets are made of particles, gas, dust, and they do not have solid surfaces. Okay. Terrestrial planets, like Earth, they do have solid surfaces because we need something to... Okay. Terrestrial planets, like Earth, have solid surfaces. They also have moons. Wait. Terrestrial planets like Earth have solid surfaces, and this is important because if we were on a Jovian planet, we would just fall right through. There's nothing to walk on, no surface, no atmosphere. So we need a planet that has a solid surface. Terrestrial planets all have moons, and as we know, the Earth has a moon, which means that our Earth-like planet would also need to have a moon. Yes, these are just some of the small characteristics of Jovian and terrestrial planets, and we need to find one that is Jovian. So that's what it means when it talks about rockiness, because terrestrial planets tend to be rocky because they have solid surfaces which are made of those materials. Okay. Now, atmospheric composition. This is talking about the elements that are in the atmosphere. And we have 4 main elements that we truly need. I'm going to list about 4 elements that we really need on another Earth-like planet. These are hydrogen, helium, oxygen, and carbon dioxide. Now, these 2 especially are very important because they were traced since the beginning of time, which means that they are something that we truly need on Earth. Now, carbon and oxygen, these 2 also have a correlation relationship. Next, we have oxygen and carbon. Of course we need oxygen. We use that to breathe. But carbon is also very important because when we breathe out carbon, plants take that in and give us more oxygen, which means that without one, we can't have the other. So we really need all 4 of these. All 4 of these are very important. We have just discovered the characteristics that an Earth-like planet would need to be habitable, and we have also discovered what characteristics a sun would need to support the Earth-like planet. So we are down to the last part. We have just talked about why Earth is changing, why we need to find a new habitable planet, what kind of sun that planet needs, and the characteristics of that planet. Now, here is why I explain why TRAPPIST-1F is the most suitable planet to support life. Okay. While TRAPPIST-1 is not a main sequence star, it still has the ability to support life, or just until we find a better star that can support life, which is why this can be a great placeholder. TRAPPIST-1F has a stable eccentricity, which means that it goes in a circular orbit like Earth. This This shows that the water phases on TRAPPIST-1F do not drastically change and remain stable. The inner limit of TRAPPIST-1F's habitable zone is 0.023. Its outer limit is 0.048. Both habitable zones are similar in number, which shows that TRAPPIST-1F does not have a drastic change throughout its habitable zone. It stays in somewhat of a stable orbit. TRAPPIST-1F is a terrestrial planet, which means that it has a solid surface and a moon. These characteristics are great on supporting life, and that is why I believe TRAPPIST-1F is the most suitable option for life while Earth is dying. All of its characteristics are similar to that of Earth, which means that it can definitely support life, and it is a stable planet. Well, that is the end of my lecture. Thank you for listening and have a great day.